Good morning on the West Coast, good afternoon on the East Coast, and good evening to everyone else in the world. Today, our flower optimization session is sponsored by Chopin. Who is Chopin? Chopin is an instrumental analysis technology company. So for over 100 years, Chopin Technologies, which is a subsidiary of KPM Analytics, has specialized in methods and equipment for ensuring the quality of cereal, flour, and related products. Yes, especially your flour. They offer a wide range of solutions to bakers for process and quality control before, during, and after production. Thank you, Chopin, for sponsoring this session. Today, we are honored to have Arnaud Dubat with us, and he will be presenting a session later on how to measure your flour quality. Arnaud is an interesting individual. He has an education in biochemistry, milling, engineering, and cereal science, and a master's in marketing. For the last 32 years, he has worked for Chopin Technologies in a number of roles. A leader for recent standard methods. And yes, I say that because Arnaud can pretty much memorize all the methods and spew it out back to you. Arnaud has worked at different organizations in France, Europe, and internationally, ISO, ICC, and AACC. He is an author and co-author of many technical and scientific publications, including the Alveo Consistograph Handbook and the Mixolab, which is a new approach to rheology. He is a father of two, and he's been married to his wife, Joelle, for 35 years. He is also a passionate musician who can recreate epic music on the guitar. Welcome, Arnaud.
So thank you, Lynn, for the kind introduction, and again, thanks everyone for joining us today. That's real pleasure to see so many people attending this presentation. I hope you will learn something from that, and and for what I heard until now, I think maybe what I'm going to tell you are going to, I hope, change a little bit the perspectives. So the question is, and that's a question that I have been asked many times, what is a good flower? And if I want to be honest, the best answer I can tell the people is that I don't know. I don't know what's a good flower. Potentially all flowers are good. That really depends what you want to do, what are your process, what are your formula. There are a lot of things that make that a flower can be good or bad. So that's a little bit the topic I'm going to address, that because there is no fatality. We can do something if we start changing a little bit, certainly the way we are looking about flower quality. So the aim of this presentation is really to analyze this traditional approach of flour is going to predict bread. And I think these COAs we've just seen have a very good example. The question is, does that values really help you not having any problem in production? Not always. These COAs, and we can see a lot of example of values everywhere, they sometimes miss the target of screening between good and bad flour. Many reasons for that. And I'm going to give you some example. And of course, we could be speaking for a complete day about that. I will try to shorten that. So first of all, analyze what we are doing right now. And then I'm going to share with you the approach we have been developing with Chopin over the last 15 years. And we see this is really bringing some benefit. And I will illustrate that with a real example. I mean, not theoretical, something we have been doing working with bakers. And this is based on the Mixolab. We could have done that on other machines, but you will see that the Mixolab is a very good candidate for that. So at the end, I will also give you some clues on how can you do that? Because sometimes people are reluctant to say, but I'm not a scientist. I do not have any lab. It's complicated, blah, blah. No, you're going to see it's extremely simple when we have the right approach to that. So What is baking? I'm sure you know because you are here, and certainly most of you know better than me what is baking. Baking is basically a transformation process. We are going to take flour and we are going to make a product. Okay, so it can be a bread, it can be a pizza, it can be noodle, it can be whatever. So finally, we are going to transform a powder into something that will be nice to consume. And of course, between the flour and the final product, there are a lot of things which are happening during the baking process. So then what is the potential influence of the raw material, of the flour? Basically, if we want to simplify, if you start with a bad flour, or let's say non-adapted flour, we have to translate bad into non-adapted. So if you have a non-adapted flour entering the process, it will be very hard to have a good product. So most likely, the final product will not be adapted to the consumer desires. On the contrary, if you start with a well-adapted flour, you are more likely to have a well-adapted and what we are going to call a good product, good final product. So that's basically. The bad thing is that this can also happen. You can start with a well-adapted flour, but yet the product is not good. What happened? Well, that means that the resulting of the process, which is the final process, is not only a matter of flour. There are a lot of other things which are also impacting the final quality. Just one example, if you bake too long, your product will be burnt. And that's not an issue with the flour. It's just that the process was not conducted properly. So we could multiply that about what is happening during forming, during mixing, during proofing. All these stages will have an impact. So flour is a part of the answer. And today I'm going to speak about the direct impact of flour on product. I'm not going to consider all these ingredients that we can or improvers. Just think about clean label, where the final product is more related to the flour properties. So Lynn showed us some COAs that we can have with of course devices I do not recommend, but for obvious reasons. We can do the same. If you start with Chopin equipment here, we can deliver a table like that, which is able, I could maybe, try to find something here. Yeah, you can have parameters, for instance, from the alveograph for cookies or cakes or baguette, or so. These are values, indicative values. So I started by telling you, if you ask me what is a good flour, I don't know. But here you can say, yes, you know, it's written here. You know that for doing a cookie, you need a p-value on the alveo of blah, blah, blah. Honestly, I don't know your process. I don't know what you are looking for. So that gives you an idea. We know that we have big classes of flours between, let's say, soft wheat product or hard wheat products. So that gives an idea. But there is very little chances that what I am showing you here is adapted to your process. And that's all the problem. That's all the problem, because if you just take numbers from the literature, for what you can find on the internet, and try to adapt that, you can get into troubles very easily. It won't be a catastrophe, but it might not be yield the result you are expecting. So then you are going to tell me, well, you're telling me that I need a P of about 40 to 60 to have a nice cookie and it's not working. Yeah, it can be, because maybe your process, your formula is different and you need another kind of flour. So then the question is, okay, so how can I define the flour that is good for me, not good for everyone, or a kind of average value? And that's all the problem, because if you just rely on these things which have been written sometimes 50 years ago, the things have changed. I mean, the process have changed, the wheat have changed, a lot of things have changed, and your process is unique, is specific. So that reaches the point where traditionally, and that's the example we just have here, that we are used to specify flour, or to speak about flour quality in terms of protein content, amylase activity, folding number, dough rheology, water absorption, dough behavior. We have been speaking about the MTI or stability or development time. I was looking at the numbers. If you look at the standard method of the farinograph, you will see that the machine, its repeatability, reproducibility, its performance is not able to really discriminate between an 8.3 and a 9.5. You are within the tolerance of the machine. So there is a big uncertainty of putting that. So we also need to deal with that. We need to have precise methods that make you have a good discrimination on the flour. And for that, that will be maybe another topic we could speak about. I really encourage you to have a look to standard methods, which are telling you what is the precision of the method. And a lot of the methods we are using sometimes are not extremely precise. Then the second thing is that, okay, protein, I need a 12% protein, or let's say between 12 to 13. What happens if I have 11.9 or 13.1? Nothing will happen. It will not change. So we are sometimes putting specification and sometimes rejecting flour based on these COAs, but sometimes we are not looking where we should be looking. The other thing is that a lot of bakers, when I've been traveling, they do not have labs. They do not control that. So they only rely to the information which is given by the miller. So of course, everybody is doing a good job. But if you don't control, you're taking a risk. Because I can tell you my flour is 12% protein. If you don't control, I'm safe. Of course, I can have problem, and we are going to discuss, but I mean, there is a need for controlling. But the question is, okay, you need to control what is good for you. And that's the point where I want to go right now. How can we change this paradigm and make it something which can be more efficient for you? We need to really go back to basics and what we want to do. We want to transform flour into final product. And between the flour and the final product, there is your process. Not everyone's process, your process. That's a specificity for you. So maybe what is good for your neighbor doing the same kind of product should not be exactly good for you. Maybe you could do better if you really work on your process. That's all the idea I'm going to develop right now. What is important finally, it's the final product, because the consumer is going to buy your product because they like it, because it's consistent, because it has a nice crumb or whatever, because he likes it. Once again, this is extremely subjective. A French baguette in France is very different from a French baguette in Chile. Not meaning there is one which is better than another one, but the consumer in Chile is looking for something which is different from France. So you cannot take what's happening in France and transfer it into Chile, because maybe the consumer will not like it. We had some example of that, of people copying things, and in fact, it was not working. So we need to take that into consideration. What are the key parameters? Volume, color, crumb structure, these kind of things. And today we are very lucky because we can measure that. We have tools for measuring all these parameters and have an objective measurement. We need to get out from subjectivity. That's also a very important point. So we need to have this. And here in the process, we have so many variables. I mean, we just have to go and look at Bakerpedia and all the topics we are discussing. We know that the formula will impact. If you are putting eggs or milk or fat or whatever in your product, and the quantity you are going to put, that will change the dough behavior. The process, the machines, temperature, the times, human factor also is very important. So are you sure this part is always consistent? Because if this part is always changing, you can have the most constant flour, the final product will vary. And then maybe you will blame the flour for not being consistent, but it's not the flour which is not consistent. It's the process. But if you do not control the flour, how can you know? So that's something we need to take into account when we speak about what is a good flour. So finally, the flour quality should be specific to each baker. Of course, we will keep groups of ideas, but it could be something specific. And also, it could be interesting to look about what is good for you. What are the interesting parameters? Everybody is looking at dough stability, and for the reason that Tin explained. I'm going to show you an example where even if you look at dough stability, and even if dough stability is under control, you still have problem. Why? Because the problem does not come from dough stability. It comes from something else. And you need to know what is important for you. So let's look a little bit about the Mixolab. So I go back to my table. So if we want to have ideas of what specifications are for Mixolab, we can give you ideas like that. So we can see different points, different parameters, but all of that seems a little bit different. And maybe for most of you today, you don't even know what is C1, CS, C2, C3, C4, C5. It looks very technical. So first of all, let me introduce you very briefly what is a Mixolab. The Mixolab is this tool. So it's basically a mixing machine. Okay, so we are going to produce a dough and mix it. So hoping the video will work. Here we go. So this is the machine, okay? And here in the mixer, you can see we are creating a dough. So we are starting with flour, we are adding water. And so we can, for those of you who know the Farino graph, that's the same principle. We are going to add water until reaching a certain consistency, and that will give us our water absorption. And then after, we are going to look at how the dough is behaving during mixing. The new thing is that we are going to heat up the dough. And when we are heating up the dough, we are decreasing the consistency here because the gluten is weakening. And that's a very important information. Think about oven jump. What happens when you are putting the bread into the oven? And then here, we are going to measure what happened to starch. All this phase here is what happened to starch. Starch is gelatinizing. And then after, you will have the stability, which is related with amylase activity. That's what we say, okay, the color. The viscosity here will influence the structure, the crumb structure of the bread. And here we are cooling down, and so we have an increase of viscosity, which is a good indicator of what will be the shelf life. So to make it short, because maybe we can have another talk where we are going to describe precisely the Mixolab, but basically that's the unique tool. There is no other one, which is giving you an information on the protein behavior, which is this part here, and the starch behavior. You can have the same kind of ideas if you are looking devices like RVA, for instance, but RVA is working on the batter. When you are doing a bread, you are not processing a batter, you are processing a dough. And what is happening to the starch, the interaction between starch protein, you must see that in the dough system. That will give you much more information. So that was all the idea of the Mixolab. And you will see very soon that this idea is bringing us a lot of very valuable information. So at the end of the test, after this mixing, okay, it's very easy to do. So we have a curve here, that's the torque. We are measuring the consistency of the dough. So you see that's the different phases. I'm not going to detail that. We have different points here. That's the point where we are measuring the water absorption. Here we are looking at the gluten stability. So we are measuring stability. We are measuring dough development time. We are measuring all these traditional things. And here we are starting seeing something new. What happened to gluten here when we are heating up, and here the starch. So that's the curve. And here you can see a kind of spider web. And I'm going to speak about the spider web right now, because this looks a little bit scientific. And yes, it is scientific. We have a lot of development teams working on that. And you might say, no, I'm not a scientist. I don't want to make science. I want to make quality control. And I totally agree on that. And this is the quality control tool. And this quality control tool is called the profiler. So let me show you how does that work. So we start from this curve, which is done by the machine. So you don't even know what's behind. Forget about that. But this curve, we are going to transform it like this into this spider web. So each phase of the test is going to receive a number from 0 to 9. And so we can have what we call different profiles. Here we have a profile for a pan bread, for instance. And you can see 6 indexes, which are absorption, mixing behavior, the gluten behavior when we heat it, the viscosity, there's the starch, amylase activity, and setback, retro. And this is where the tool becomes a quality control tool, wonderful for bakers. This is a curve translator. So you don't need to know the science behind. You have the translation. So it takes the curve for you. So this complete curves, it takes it for you, and it makes it very simple to say, okay, water absorption will receive an index from 0 to 9. It's good for South American friends. Here we have a very high water absorption. It receives 8, okay, for instance. And then we are going to look at the mixing behavior, and here it will receive a 5. Okay, so we have made all the calculation by analyzing thousands of different samples, and so we have been creating this scale for all kind of flour. Okay, so we are going to have 6 indexes for water absorption, mixing behavior, gluten behavior, starch, amylase activity, and retrogradation setback. So the work is done. Now you are going to create a profile. That's your job. So what are you going to do? You're going to start observing what is good for you, what is working for you. So first thing, you are going to select every flour, and I imagine that's the biggest number, all the flour which are working good for you. Okay, you test the flour, and then you will have this little spider. When you test different kind of sample, you will have a minimum maximum value, which corresponds to well-performing flour. So you know what is good for you. Look at this example. We've done that with a pizza manufacturer, and the green area correspond to all the flour which have been performing well. If you are doing croissant, you have another kind of profile here. And if you are doing pan bread, you have another kind of profile, which is corresponding to well-performing flour. Interestingly, when we have been working with different companies doing pan bread in different areas, I think there were UK, Brazil, and I think US here, we see that for the same product, we do not have the same profile. Why? Because the processes are different, because the type of flour they are processing are different. So of course they need different flours at the beginning. Okay, so once again, it's very specific. So here I go to my example. Test and transform, this is done by the machine. Then after you can look if the flour you've just been analyzing here it's not fitting, it's outside of the profile, it's out, and here it's in. So if it's in here, we see that that's a pizza profile. So it means this one is good for pizza, but it's not good for doing pan bread. So an example we have been doing with a baker I was mentioning at the beginning. The first thing, you have to define your profile. Very easy. Here we took 20 samples. We received 20 samples, and the baker told us this sample, we had no problem. We had a good product. We are happy with this flour. And so we have been determining the green area. And you see it's quite large, okay? But that's corresponding to well-performing flour. And then after we said, okay, let's try to make a test. Now we have built the profile. Let's try new flours. And on these new flours, we had 15 which were good ones and 6 which were bad ones. They were not satisfying. They were not giving the right product. Okay. So this is how we are going to treat that. We put all the good flour here. So that's the green dots you can see here. And we put all the bad flour here at the end. Okay. And the two lines here correspond to the minimum maximum of this index. Here, that's the absorption. And you can see here, where are the results. If you look at the 6 indexes right now, we can see that for the absorption index, you cannot discriminate between good and bad. They are all within the range. And it's the same for the mixing index. Okay, basically they are all within the range except 2 ones, but there is one good, one bad, we cannot decide. But look, when you start looking at the gluten behavior when you heat up, all the good are around the good values, and the bad one, they are outside. Same thing for the viscosity here. Here you have, on this table, you have all the sample, and when it's written in, that means it is within the accepted profile. And what's interesting, so in these new samples, we can see, okay. So all the bad flour, so what the baker told us, these are bad samples, I had problem with that. They all had part of the profile which were out of the ideal area. More interesting here, oops, all the flour which were completely in the profile, they correspond to well-performing flour. And it's not a surprise because we built the profile based on the observation on what is good for the baker. And as always, no, I don't think the world is black or white. You have somewhere in between, so you have some sample that can have sometimes a little bit out, but still are good. But the good thing is that if you base your specification on that, you can make sure that the flour will be performing well. And what is interesting, that absorption in mixing index here are not discriminating. The discrimination is made on what the Mixolab is bringing new. And the reason is very clear and very simple. Specifications of this baker were based on the farinograph. So water absorption and mixing properties were under control. But the problem was not coming from this part. It was coming from somewhere else. And if you do not analyze, if you do not know that, you might continue asking for the same values, but still you have problem. So that's an example. And really we are convinced that that can bring a lot of benefits, for bakers. So because it starts from you, Mr. Baker, you know what is good for you. You are the one which is able to tell me the flour is good or the flour is bad. And that depends on your product, on your process, on your product, etc. So based on this tool, for instance, you can easily determine the profile of what is good for you, which are the indicators which are the most impact, and do not waste time in looking about mixing when it's not important for you, when the important part can be amylase or viscosity or whatever. And you can build your specification not based on what you can see in the papers or what is written everywhere and available for everyone, but on what is good for you. What you need to do that, a control tool, and maybe the support of a company like ours. Time and patience, you are not going to make that in 1 or 2 days. It can take you 1 month, 1.5 months to really analyze. You need to have sample. If you do that with just 2 samples, not going to work. And of course, we need to have a good cooperation between production and lab. The lab needs to know what was working well on the production. Okay, so again, sorry for this interruption. If you want to know more, you can request a copy of this Mixolab Profiler white book, where you have a lot of explanation on how to use it and where to use it efficiently. Sorry again, and thank you very much for your attention. And I think it's time now for question.